Well, good morning, good afternoon, or good evening. Thank you for joining us today for today's edition of Connecting the Dots. My name is Richard Stager, and I'm with Ingevity. Today's topic is automation of quality assurance in asphalt production and construction. Today's speakers are Rory Charlesworth, and he's got 14 years experience in technical and commercial roles in the asphalt industry, focusing on highways, airfield, and defense and infrastructure. As the head of commercial development and for highway data systems, he's responsible for promoting automated quality assurance technology that we will talk about today, and in both the U.S. and in the U.K. He's helped shape the market understanding of this technology, which, through highway data systems, has led to specification changes at Transport Scotland, National Highways, just to name a few. Also speaking today is Matt Wheatley, who is the president of Highway Data Systems. Matt has 30 years experience in the industry in both the US and in Europe. He's a former associate member director for TexAPA and has been actively involved in standards development through ASTM International. And with that, Rory, we'll let you take it from there.
Thanks very much, Richard. I will just share my slides. Can everybody see that okay?
Yes, that looks good.
Okay, fantastic. Right, well, good morning, everyone. Thank you very much for having me. Thank you, Richard, for that introduction. The company that I work for, Highway Data Systems, we're going to be talking about automated quality assurance for asphalt production and placement. So first of all, just a little bit of background about us. As you can probably tell, I am not an American. We started up in the UK, where we are a UCAS accredited materials testing house. What that means is UK accreditation service. So we are all from a technical materials testing background. I myself started off as a technician when I was about 18. I've been in the lab, I've been out on site. I'm quite pleased to say that now I spend most of my time in an office, so it's a bit cleaner. But the background really is materials testing. So rather than being a technology company that's come into the industry and trying to apply technological solutions to the industry, we're very much from the industry and have identified ways to use technology to improve processes. So we operate our hardware and software that we design in-house as a service for contractors. And we have 46 squads and 16 plants. I think actually that number might be a little bit out of date. Matt will probably explain to you how many we've got going in the US, but operating with our technology across the UK, Ireland, and the USA. And we are the sole provider of this technology on frameworks, including Transport Scotland, National Highways, and the UK, and Europe's biggest airport, which is Heathrow Airport. So here are some of the issues that we identified as requiring improvement in the asphalt construction industry. The first is health and safety. There are many and significant health and safety risks with doing anything on site, as we all know, and any opportunity to use technology to avoid that is a pretty self-evident benefit. From a technical point of view, we think that because of the way that quality assurance is done, it's often done after construction, and that means that there's a limited opportunity to fix problems before they become permanent. I'll get on to talking about compaction testing in a minute, but that's a pretty good example. And another thing, for anybody who's worked in the industry for any amount of time will know that there is often a limited degree of communication between asphalt production parts of the business and asphalt contracting, and that causes issues. And it has, negative impacts on quality assurance. So we really thought that was a good area to look at for improvement. Next, opportunities for CO2 reduction. It's a very important topic. Everyone across the industry is trying to do everything they can, but there are some opportunities being missed by the lack of sophisticated technology being used during particularly the asphalt production process. And then finally, one of the issues that we identified is that none of the data that we use really in construction quality assurance tends to be used during asset management. And we think that it stands to reason that if you if you know more about how the road is constructed, it should help improve your understanding of how the road will perform during its life cycle. So those are some background things that we wanted to try and improve on. In some more detail, this happens on networks around the world day in, day out, and it's capturing material delivery temperatures. If you're sticking your hand into very hot asphalt around moving machinery, not only are you likely to be capturing only a couple of data points, maybe the material will tend to be cooler at the back of the truck, but you're putting yourself into danger. And if you think about all of the operations that technicians have to do around the paver, whether it's doing, rolling temperatures behind the back of the paver out temperatures, delivery temperatures, creating construction records based off ticket information, it's actually quite difficult for that technician to keep up and record all that information diligently and accurately. So we think there's some opportunities for improvement around those processes. Secondly, compaction testing. So first of all, I've got to say that we don't think that density gauges are especially reliable. We've done a fair amount of correlation work, and we think that they are more affected by things like temperature than may often be acknowledged. But from a practical point of view, this is normally done after the construction's finished. The guy drops back after laying X number of tons of base or binder, and the material is going to have cooled significantly by the point at which the testing's done. And that means if you find that some of the material is out of spec, then unlucky really, because there's not much you can do about it at that point. The accuracy of density correlations is it's variable. I think particularly with increasing amounts of wrap going into mixes, we think that basically there's opportunity for doing compaction testing in a better way, basically through the use of technology. And finally, the data. The way that we collect quality assurance data at the moment is pretty old-fashioned. It means that the resulting reports that you get out of it tend to be siloed. There's not much opportunity for doing big data analysis. They don't tell you much about the project progression, and they tend to be change reference, which means that the data doesn't upload nicely into GIS visualization platforms. So I'm sure I'm not telling you anything that you don't know already, but it's just good to start off by explaining what problems that we're trying to overcome with our approach to quality assurance. So I'll just show you this quick graphic before I hand over to Matt to talk about our asphalt production systems, but I wanted to just point this out as where all of this technology sits. We're very keen on the idea of connecting asphalt plants to asphalt sites, and we have instrumentation and technology which covers the production, dispatch, transportation, installation, compaction, as well as surface testing, and all of that data is available in dynamic formats through our HDS Insights platform. So Matt, I'll hand over to you now.
Thank you, Rory, and good morning. And for those of you the more observant will note that I am also not originally from the USA. However, I do reside in the USA and have done for 20 odd years and based in Texas. And the next couple of slides and the technologies that I'm going to show you, these have been developed in conjunction with different stakeholders here in Texas in response to their industry needs and requests. And maybe before we kind of get into it, maybe a good analogy for these technologies is maybe how behavior changed within your organization if and when you introduce dash cams to your company or organization's vehicles, and how the behavior changed, because it's a similar effect. When there is visibility of data, behavior may and often does change. But the first thing we're going to look at is what we term our e-plant system. And as you can see, this is a real install at a plant in Texas. We have an infrared sensor that records material at the drag slat as material is produced. It measures the temperature as the material leaves the drum before it is transported to the silos, to the storage silos. And we use cellular or Starlink to send the data off site, and the operator is provided with a tablet in his control room or her control room to view live data of the live temperature of the material they're making. Go to the next slide, please, Rory. The next technology that was we developed, again in conjunction with industry, was what we term our e-silo system, where we mount infrared sensors underneath the eaves of the silos. As the silo door opens and material is released, we capture the temperature of the material. We then tie that to the loadout ticket and report this information in real time for the plant operators and owners. We also store this data in case of emergency. And the slide that you're seeing here, the red circles are the infrared sensors that are underneath the eaves of the silos. And as you can see, our control box is magnetically mounted, and the silo sensors are fed to this box. And again, we use either cellular or Starlink to send the information off of site. Could I have the next slide, please, Robin? So here you can see a truck is leaving the plant. And as you can see, the operator has a live tablet showing them that truck loadout with the temperature of the material. And therefore, they can ensure that the material that they're shipping is within specification. We like to call this encouraging positive client relations. In other words, for the contractor or the producer of the material, they can prove that the load that they loaded and the temperature and the time that they loaded that material and can settle disputes. We can look at the next slide, please, Rory. And we show this data in a couple of different ways. So the image that you're seeing on the left is a more traditional tablet view, where you can see the truck information, the type of material, the tonnage, depart time, and the temperature of that material as it was loaded. But on the right-hand side, you see, and the reason I show you this is I can't really explain this, but plant operators prefer this view, which is the last drop they're making out of a silo into a truck. And we're not really sure why, but they seem to take some comfort from that. And it seems to give them that comfort that that immediate drop they just made was within tolerance. So we're now capturing production information in terms of what the material was made at, and we can now also see what the loadout temperature is going into the back of a truck. So this data is then transmitted to the paving crew, and Rory is going to show you some of the technology at the paving crew and how we collect that data.
Thanks, Matt. Yeah, so this picture here, this screen, is what we use for creating laying records. It's a pretty simple system. Basically, when material goes over the weighbridge and a ticket is created, the HDS system receives the information from the asphalt producer, and we send it ahead to site. So this is a tablet screen basically on the side of the paver. When the material gets to the site and when it's discharged, the banksman or the dump man, as I think they're called over there, will press this vehicle registration button. That drops a GPS point around which all of the temperature information, all of the ticket information is then associated. So we have a GPS record for where every load of material has gone on site. It removes the requirement for having somebody standing down scribbling information, and it also helps to it digitizes it and it creates a geospatial record as well. A couple of things worth mentioning on this is that we have a depart time. So anybody who's had the fun experience of phoning an asphalt plant and asking where their material is, you'll normally get told that it's on the way, even if it isn't. And what we find is the guys on site quite like to know when it actually has left. So apart from just being a nice to have, there's actually a technical benefit from that, in that the guys on site can actually regularize the speed of their paving, and that helps to reduce thermal segregation. We send the dispatch temperatures ahead to site as well, so that the paving crew have got full confidence that they're receiving material within the right temperature spec. So it's got a couple of nice to haves for the crew, but I think the benefits around quality assurance are more around the digitization of the reporting and the removal of the manual process. We also instrument pavers with a system we've called eTech. eTech consists of a GPS on the roof of the paver for tracking the movement of the paver, an environmental monitoring system for capturing environmental information, and 2 infrared temperature sensors which we point at the augers. The reason why we point the infrared temperature sensors at the augers is because when you're using infrared to measure asphalt, you want to have the asphalt moving if at all possible, because as we know, the top layer of asphalt, as soon as it's exposed to air, will tend to be quite a bit cooler than it will be in the middle. And we also think that by the time it's been mixed through the flights and by the August, then you're going to have a more representative temperature. So we continuously monitor the temperature of the asphalt, and using the GPS and the time stamping, we match up those temperatures to the e-load tablet, and we have a delivery temperature for the asphalt without the requirement for any manual testing. You'll have to forgive me for showing degrees Celsius here, but we do have it in Fahrenheit, I promise. This is so that the guys on site can have access to the information. So we have the delivery temperatures as well as some averages and the environmental information as well. That's all available through the ESEC app, which we have on the tablet there. The next system that we employ, and I think this is reasonably well used in the USA, it's becoming more popular in the UK as well, is a backwards facing thermal imaging camera, and it's used for measuring thermal segregation. So what you'll see on a readout here, this is an example of basically pretty bad thermal segregation. The purple lines here, these are paver stops. This is where the material has been cooling under the screed of the paver. And then when it's revealed, it's captured by the thermal imaging camera, and you'll never guess where you end up with potholes. It tends to be in these areas. I've got quite a good little example of that here. You can see on the left the thermal segregation data showing cold spots, and then here, although it's slightly difficult to make out, these are the premature failures. So it shows the importance of having not only measures in place to reduce instances of thermal segregation, but also how important it is to capture that information to make sure that well, the contractors are performing as well as they should be, and I'm sure they would like to be. So yeah, this system we've had it specified by Transport Scotland, and it's quite interesting looking at the difference between the USA data and the UK data. I think it's fair to say that the USA data tends to be quite a bit better than it does over here. You've got more space on your roads, and I think investments in shuttle buggies and material transfer vehicles on USA construction sites really does help to improve the quality of thermal segregation. So it's really great to see that over there. The next system that we employ is a system called Optrix. And Optrix monitors roller movements as well as infrared, has an infrared system for capturing rolling temperatures. So as you can see from this, we have a GPS sensor on top of the roof. We used RTK correction to give an accuracy of up to 20 centimeters. So it's a highly accurate GPS system. The infrared temperature sensor continuously captures the rolling temperatures of the material, and we feed all that information back to the roller driver via a visual aid inside the cab. Now, the way that we use this for doing compaction monitoring is through the use of correlations. So we're just at the moment writing a specification for the use of this system at Heathrow Airport. We're working with AECOM, and basically the way that we do this is through a trial panel and with sacrificial material. So we'll build a compaction curve demonstrating the number of passes required to achieve your desired compaction, and then we plug that data back into the roller screen, into the roller system, set the color to be green when it goes over the desired number of passes, and then we tell the roller drivers, go and roll it all until it's green, which is nice and easy to understand. It's worth mentioning that this does not rely on stiffness measurements. I know there are some roller systems out there which try to use stiffness for capturing density information. We don't believe that those systems are reliable, because you can have a cold material that's gone stiff. It doesn't necessarily mean that it's dense. And basically using density is a complicating factor too far, really. We think method compaction is perfectly reliable. If you have a homogeneous mix and a set weight of roller and a consistent thickness and the right temperature, you will be able to predict the compaction of the material. So all of the rollers on site are connected with this system. All the roller drivers have full visibility over each other's operations, and in theory you should leave with a nicely compacted road with a very clear output for compliance checking. The final thing to mention on the technology hardware side is laser surveying. We do this in the UK. We are yet to do it in the US. Not sure what your thoughts are on that, Matt, but we'll get to that later, maybe. So currently, we use laser systems that we developed ourselves for capturing surface macro texture and a measure of surface regularity, which is called the rolling straight edge in the UK. But basically, we send the vehicles around within a week of construction, and we capture the surface macro texture, which is a safety critical component in the UK. And then the smoothness with the lasers as well. And we've actually developed some new lasers which can do quite a bit more. So, you know, MPD testing, SMTD, ride index, and what have you. So at this point, I'll hand back over to you, Matt, to talk about some of the outputs.
Awesome. Thank you, Rory. So as Rory's just shown you, we have lots and lots of ways of gathering huge amounts of data. But then the challenge becomes, well, what do you do with that data? Well, we have built a gateway, which we call our HDS gateway, and it's a dynamic platform for managing AQA data across multiple shifts, schemes, and data sets. It brings together all materials testing information into one location. Contractors can produce reports, interrogate individual data sets, and track productivity trends across multiple schemes. Go to the next slide, please, Rory. And we only grant access to authorized users. So we provide you with secure login and username details so that only authorized access can gain access to this data. Go to the next slide, please, Rory. And something this may be more relevant for the contracting community. However, what we've determined is that a series of these the data points here can produce critical KPIs, which can show you how much material your plant is producing, but it also allows operational maintenance decisions to be made based on usage characteristics. And a great example of this is a series producers didn't realize that they were consistently relying on specific silos at specific plants, and now they share the workload amongst the storage silos. So you can gather huge amounts of information from this data over a period of time if you start to build up various plants, what they're making materials at, different temperatures, and you can track that across all of your different production facilities. Get the next slide, please. So that's great for a 30,000 foot view, but now I'm going to show you a little bit more kind of dig down into some more project specific data. So the next couple of slides that we're going to show you are from some data collected from a project in Oklahoma. This data was part of a climate challenge project carried out by Oklahoma State University by Professor Deb Mishra and his talented team. Both hot mix and warm mix data is presented from different consecutive days' efforts. So temperature and location data was collected at the drag slat, silo loadout, arrival at the paver, uncompacted mat, and then during the rolling effort, as Rory's just explained. However, let's have a look at this plant production data from day one, which is what you're looking at right now. This was an S3 PG6422 hot mix design with a production target of 300 degrees, and it was on July 30th, 2024. And as you can see, it's fairly fair to say that the plant I'm not a plant operator, I should stress, but the plant operators did a pretty good job. Their mean temperature was right around 300, and just a little specific information about this project. This was an Aztec portable plant, which has a hopper, which has a capacity of about 80 tons. And essentially, once that hopper's full, if there's no trucks to load the material into, you have to stop the plant. So these stops that you see here are related to that. There was no trucks available. The producer just had to shut the plant down. He has no choice. But as you can see, they did a pretty good job of keeping that material in good condition within specification. So can I get the next slide, please, Roy? So this is now the matrix of that same material being delivered by each truck, the delivery at the paver temperature, the rolling temperatures, and the GPS location of each individual load from that first day. So you've now got complete control in the sense that you've got a complete holistic overview of the temperature it was made at, the temperature loaded out at, the temperature it was arrived at the paver, and the temperature it was rolled at. Get the next slide, please, Rory. Going to look at the warm mix now from the same project, but the next day. And now what you're looking at, so we're now looking at the temperature at day 2. Same material, S3 PG6422, but with a warm mix additive, but now with a production target of 250 degrees. And this was on July 31st. And again, I'm not a plant operator, but I'm told this temperature increase that you see at the start is very common practice when using warm mix additives, that they'll they'll have the plant running a little bit warmer until they're comfortable, and then they'll drop it down into the temperature range that they're looking to produce at. And again, as you can see, on a mean temperature, the folks did a pretty good job. 255 was their mean temperature. So they did a pretty good job of keeping this in spec. Could look at the next slide, please, Rory. And again, now it's the same matrix that you saw earlier for the hot mix, but exactly the same principle. You're now seeing the truck loaded temperature, delivery at paver, rolling temperature, and GPS location of each load. So we go on to the next slide, please, Rory. And we are not doing this live for a reason. We've watched Meta do demos that spectacularly fail when they rely on the internet. So we have deliberately used screenshots for the purpose of this. However, imagine this is an online portal, because it is an online portal. And now you can see this is the data from those two matrices that you just saw. This is each individual truck and its location plotted on the location that it was actually deployed. And if I was online and live, I could click on one of these and it would show me the ticket number, the temperature, so on and so forth. Get the next slide, please. And again, in the same location, we can overlay the thermal segregation information. So now we're not looking around for PDFs that may or may not have been sent. Everything is in one location. So everything can be viewed from your fingertips and very, very quickly. And if we could have a look at the next slide, please, Rory. And now you can see, as Rory mentioned, the rolling patterns, and what you're now seeing here is this: is that if you're 1B in Texas, your inspector says the rolling pattern is 10 passes, then each roller is programmed, and then this is the data that you see and can come in and again inspect from your zoom in and out to your heart's content. And we can also look at the temperature of the roller. This is showing the passes, but we can also look at the temperature of the rollers as they made their first passes as well. So all the data is stored in one central location for ease of access. Can we get the next slide, please? So developments in kind of Texas and beyond. We're based in Texas, so we now have installs of over 30 different systems, both plant and silo systems in Texas. The development of these critical KPIs is no question is driving a really deep understanding of plant production and operational parameters for the owners. The adoption rate that we're seeing is significant. What I'm driving at is that contractors are willing to do this for their own purpose because it's a CYA. It's information they didn't have previously. And it's proving very valuable to them commercially. So we are involved in development of standards, and I'll talk about that in a little bit in a moment in Texas. But also we are working, as Rory mentioned, we're working with a leading UK consultant to develop a standard for Heathrow Airport. And we're also working with the ASTM DO4 committee to make a draft submittal in early 26. TxDOT is leading the way, and I'm not meaning to be rude to other states, but TxDOT seems to be trying to lead the way in incentivizing procedures to producers to use warm mix and lower temperatures. And if you get the next slide, please. So here we have a kind of just a time. I'm not going to walk you through this, but essentially I'll talk you through it, which is that industry here in Texas tried to measure. Initially, there was a suggestion that we should measure the temperature at the drag slat, and the industry was not crazy about that idea because there are a lot of variables. There are a lot of variables at plant when you're starting up, shutting down, so on and so forth. So subsequently, there was a little pushback from industry on measuring at drag slat. Subsequently, we've now gone back to, we're working with the Austin district, and subsequently, we've gone back and have now developed two standards, or we're working on developing written specifications for a dense grade mix and a thin overlays mix, which are both widely used in the Austin district. However, this new standard is now measuring the temperature of the material as it is loaded into the truck from the silo system. And because of that, and because many of the producers are already using this system for their own purposes, we anticipate that this one-time use specification is likely to be approved. And we get the next slide. This is just a quick summary of that paperwork or that standard that's under consideration right now. And that's just a kind of quick summary of some of the work we've done here in Texas. We've only been going 2.5 years here in Texas. So we've been really thrilled with industry's response and the help and the guidance they've given us. So with that, I'm going to hand back over to Rory.
Sorry, I realised I was on mic there. Thanks very much, Matt. So to summarise, automated quality assurance. As we said from the start, there's a real big health and safety benefit from getting people away from doing manual testing, and there's some cost implications of that as well. But I think health and safety is the main driver. We like to think that by providing real-time quality assurance information, we're going to help prevent problems from becoming permanent. Better temperature control certainly will lead to better use of additives in warm mix. It'll help avoid damaging binder. It'll help reduce energy costs. And I think, the silo stuff certainly has got its benefits in terms of, maybe acting as a little bit of an insurance policy against material being sent back for supposedly being too cold when it hasn't been. And then finally, it'll be interesting to see where we go with this in the future, but we do think that a lot of this data can be used in asset management and deterioration modeling, because it makes sense to get the benefit of this information for more than just during the construction process. And with that, I will finish up and ask for any questions.
Thank you, Matt. Thank you, Roy. Appreciate the presentation. I failed to mention at the beginning of this that if you had questions and you want to put them in the Q&A, we'll walk through those. I do know that we have Dr. Mishra is actually online, and he put a couple of comments in the chat. So, Patty, I don't know if can they see the chat in this?
I believe they can, because Deb is just a participant. So.
Okay.
If not, what I'll do is I'll send those, the attachments that he put in there. I'll include them in the post-webinar email so that everybody has them as well.
Very good. Well, if you're online still and you want to look at one of the graphs that Dr. Mishra generated, this came from one of his research reports. It's based off the Oklahoma climate challenge project, where they did use the system that Matt and Roy just discussed, and it shows the difference. It shows the differences in hot mix versus warm mix at the various points of measurement, which we found to be quite enlightening. It shows the differences in temperatures at production, loading, unloading, and then the compaction process. And then he wrote a good paper about that. I'm asking him to see if he can put a link to that in the chat also. Also, he generated his students also generated a YouTube video on this whole project. If you're interested, there's a link to that in the chat, so you can watch that video. It's about 3 minutes long, and it shows it's essentially a movie that so we didn't want to show that real time here live because of our uncertainty about the internet. But anyway, you can watch that on your own time and see what you think about how that process worked for this particular project. So with that, do we have any questions? Not yet. Well, we can open the floor, I guess, to questions if anybody's would like to ask these guys, since we have them online. Can we open up? I assume we can open that up. Patty, can we turn somebody's mic on?
Yes, I can turn it on. Give me one moment.
I believe Stefan Charmeau has a question.
Okay, give me 1 second. All right, Stefan should be able to chat now.
Stefan, if you want to.
Hey. Yeah, I think I got it. Hi, I'm Stefan Charmeau. I'm with Ingevity as well, based in Charleston, South Carolina. Thank you, Rory and Matt, for your time today. I think it's really great what some of the tools that you're bringing to the industry, instead of having us running around with temperature guns and shooting maybe sometime the mix, sometime the sky, and all the advantages that you shared today. I have a question. Besides seeing your system in action, which is really outstanding, the data that you can generate. The question I have is, you mentioned, I think, Matt, the spec progress, and do you have any more details as far as where you see maybe some agencies going to? And, you know, I think that that's usually maybe the best way sometimes to have some requirements, you know, specifying what the end result should look like, and you know, then people kind of trying to achieve that. So do you have any maybe update on the progress there and where you see things are going, and maybe some examples that are great existing already
Sure.
situations?
Yeah, I mean, I think in terms of the standards, Stefan, that's a great question. And again, it's not that I don't want to tell people. I think it's probably fair to say though that we're in not a holding pattern, but we're in a place where we're waiting feedback, particularly in Texas. I'm talking specifically in Texas. We're awaiting some feedback from the community or from the contracting community. However, I think it's fair to say that most of the contracting community here in Texas that have used these kind of technologies for automatically collecting data approve of it and like it, and I don't think we're going to see the same pushback that we probably saw when there was a more of a push to measure at drag slat. I think the concerns that producers had about measuring at drag slat was probably viable. There are a lot of variables there. So in terms of if you want to know what you're paying for commercially, then it's probably better to measure it going into the back of the truck. So in terms of the timeline, I believe, Stefan, that we would anticipate, and this might speak to the future a little bit as well, is that the Austin district uses a lot of that dense grade mix and thin overlay mix. Although unfortunately, weather-wise, we're at the end of the season probably for the tom mixes in Austin now maybe till February or March. But what we anticipate to see is probably a few jobs let, hopefully in the next coming months, Stefan, and I believe that what we as an organization in conjunction with other stakeholders will probably do is probably then look to work with other districts that would like to replicate this kind of incentive for their producers to use warm mix. And certainly, as you know, in Texas, the community is quite well developed, and I think that we've got some positive feedback, let's put it that way, from different districts that might be interested in pursuing this. So I think that's where, in terms of the short term in Texas, that's probably where we're going. But I don't want to put the horse before the cart, so to speak.
Yeah, thank you, Matt. Sounds like a great start, and you guys have been working hard. So thank you.
It looks like we have a question from Cody. Patty, can you unmute Cody so he can ask his question, please?
Yes, give me one moment. I can't find him in the list of participants. Give me a second, guys. Sorry.
I think I can do it. Cody, you can go ahead and come off mute and ask your question.
Hi, good morning. This is Cody Holamo. I'm pavement preservation engineer for Massachusetts DOT. This is a great question there, and some of the stuff you just said there, Matt, I think we may be interested in pursuing some of that as well. We actually we just put a project out this year. It'll probably start paving next year though, that had lower temperature requirements. We're taking the temperatures, I believe, at the haul vehicles when they leave the plant. And I'll be very curious how that plays out, because I think it's probably better to have those temperatures at different locations. But definitely would be interested in talking to you guys more about that stuff. And then I had a question more about kind of like all of your guys' products there. Do they produce like a report at the end of the shift, or, you know, whether it's at the plant or at the paver type of thing?
That's a great question, and apologies, we should have mentioned that the matrices that I showed on my slides, Cody, were a page from a PDF report that we do send every day. Yes, so there is a PDF summary, and I can, if I could get your email afterwards, I can send you a copy of a demo project which will show you that full suite of data, which shows you the plant production. It shows you that whole matrices of data, thermal segregation. And the reason that we didn't want to focus on that too much is because, you know, we're trying to tell people about an online portal, and that's the PDF. So, but we do produce a PDF. Yes, is the short answer every day.
Yeah, I think it's really important for these thin lift overlays, and we've been doing a lot of that lately, because there's not really, we don't take cores on it. Temperature is a huge issue, like you just said, the end of the season. Last week was when we end our stuff for the thin overlays at 3/4 of an inch with the spray paver. And I know we've discussed having that added to the spec for that. It's just a matter of how we're going to do that in terms of monitoring temperatures. A few years back, we demoed the PaveScan tool, but it still has never come to anything, you know, yet. But I think there's a few opportunities we have to make that work.
And to give you guys a sense of what Texas has done, and I do think this is, again, I think if you recall some of the data from the warm mix, for example, where the plant was started at higher temperature, then came down into specification. So the way that Texas is wording its specification for capturing temperature out of the silo, but incentivizing that, is to say, well, you can ignore the first 5 drops of the day and the last 5 drops of the day, which, and then what they're also saying is we want to see your low temperature, your high temperature, and your median temperature, and that you're gonna get paid based on those characteristics. So it's a very, in my view, that's quite a fair way to look at that data set and say, okay, this is what you produced for that day, and we'll pay you a bonus potentially, or incentivize you to try and keep within that temperature window.
One last thing, I guess, while I'm unmuted here, I get a chance to ask you some questions, and then I'll be done here. We have a few different things going on where, like, we are trying to do that with the temperature. It was also with the high wrap and high polymer mix, and it was kind of a really big demo project. Are a lot of contractors on board with this stuff already? Are they using it? You know, is it going to be a big lift for them? Every time we've done this, I recall probably about 15 years ago, we started looking at intelligent compaction. And I just remember the questions back from the contractors was just, how are we going to get paid for all this? You know, it's $50,000 to get all the stuff. So, and thank you guys.
Yeah, that's another great question. And I think Rory can probably speak a little bit more about some of the roadway systems, but I'll kind of try and answer in terms of the plant technologies, because I think what we found, and we've been pleasantly surprised by this, is that we have found that the producers are quite willing to particularly measure coming out of the silo, because for them commercially that is information they don't have, and commercially that could potentially save them from dispute time, and it has. That's what it's being used for. That's what it was predominantly used for early on, was settling disputes between contractors and customers. It's still used for that, but it's now also used for QC, QA, and also now for operational decisions. But yeah, that's its first and primary use out the silo was just that, was ensuring that these guys were covered. So we're seeing really good adoption rates, to answer your question, Cody, from the contracting community, because I think it's giving them something that they don't currently have. They've got to send a tech out right now to stick every truck right now.
Yeah, I'll just add to that. I think, yeah, the point is well made, Matt, that the adoption has been pretty good with the e-silo and the e-plant systems. The on-site technology, what we call Evo, is a little bit more challenging because of the cost implication. So in the UK, we've had to, it's really only worked financially when we've been able to replace somebody doing manual testing. So, you know, the money comes out of basically a saving made through reducing personnel on site. And, you know, I'm not sure how much appetite there is for that kind of an approach, but that certainly makes things a bit easier. I do think the way that you guys have for incentivizing high performance through bonus is definitely a good argument as well to make to contractors, because then obviously there's an incentive to potentially make a bit more money by investing in some new technologies. But obviously it's not something we can provide for free, so it's definitely a fair question. But you know, hopefully I think we're getting there. We certainly are in the UK, but you know, they've actually changed the specifications, so we've had to update It's called the Schedule of Highway Works, basically, and so they've allowed basically texture testing and regularity testing to be done by laser, and they will be adopting a method compaction approach to compaction monitoring as well. I don't think we're going to get rid of coring; that'll have to be done manually, but just the way it works out contractually in the UK, certainly that's how we've been able to get it up and running.
Great. Thank you, guys.
Thank you, Cody, for your questions. Matt or Ari, how many systems do you have in the UK? I mean, Matt, you mentioned you have 30 or so in Texas. Is that right?
Yeah, that's a mixture of silos, and I mean, I can tell you without breaching any confidentialities here that, you know, for example, Austin Bridge and Road monitor all of their plants, both drag slat and silos. RK Hall are going to monitor 6 or 7. We just have a contract to do. Just started with those guys. CSA have done 2 out of their 3 plants, so it's starting to pick up relatively quickly. Yeah.
Very good. I saw that Dr. Mishra is online and he had a question, so I'll open the mic up for him. Dr. Mishra, if you'd like to open up your mic. Maybe.
I just allowed it. You should be able to speak now.
Go ahead, Dr. Mishra, please.
Okay, yeah, I think it kept appearing and disappearing for me. So, hey, Matt, good to see you, and great presentation. Thank you. First of all, officially, I mean, I wanted to take this opportunity to thank HDS for all their help during our program. I mean, our climate challenge project got a lot of visibility primarily because of you guys, and it's really, I just wanted to get on record thanking you. All of that. Rory, I haven't met you in person or before, but thank you. Great presentation. I just have a question, Matt. And you remember what we used in our project. From what Rory said on the paver mounted system now, looks like it now has a GPS. So that means we can probably calculate, paver speeds and all of those kind of things now. Can you please tell me a little bit about how the sensors have changed since our deployment? Because I know that in our deployment, we didn't have a exact way to know the unloading time. I mean, if the person on the paver forgot to click it at the point it was being unloaded, then they could actually click it twice consecutively, and you'd see 10-second interval, 2 trucks unloaded, and you're like, okay, that doesn't make sense or something. So has there been some upgrades recently and stuff?
Yeah, I mean, maybe I'll let Rory answer that, because they've done some, and I will come back and answer about third-party company that we're also working with. But Rory, I'll let you answer that if I may.
Sure. Yeah. Hi, Deb. Nice to meet you. And yeah, thanks for your support with that project. It was a really great exposure for us as well. So we were certainly very grateful for that. Yeah, to answer your question, that is a real pain when the guys forget to press that button, because it messes up the GPS positioning. It actually affects the way that we calculate the temperatures as well, because some of that's done on a time-based system. So it's something which we are actively innovating to remove. So we've come up with a system that we've trialed in Scotland, which uses Bluetooth tags and accelerometers. So basically we identify each delivery vehicle with a Bluetooth tag, and we have a corresponding receiver on the paver, so that when the material is being discharged, then that Bluetooth tag will basically say, it will identify the truck. The way that we know that they're tipping is by using an accelerometer. So basically when the truck goes above, say, 20 degrees, then it will basically say that this is tipping. So obviously that only works in a particular use case where you've got a tipping truck, and that hasn't factored in things like MTVs. So maybe not a complete whole solution we've got yet, but we certainly recognize it as somewhere where we need to improve, and it's probably just going to take a bit of tweaking, I think, to get it working in a US context. The principle is sound. I don't know whether any of the hardware has necessarily changed since we did that project, but there are some additional things you can do with the data, like you can look at paver idling time, things like that. So we've tried to basically leverage some of this information to have a bit more info, like paver speed and what have you. But that's in the process of development, I think it's fair to say, isn't it, Matt?
Yeah, and just to follow on from what Rory was saying, Deb, and kind of to address the issue. As you noted, really the only part in that chain which requires human intervention is where the dumps person hits that button on the tablet and accepts the load. So we're also working with one of the major e-ticket producers to use a combination of our technology and their technology. So, for example, we might capture the temperature of a load and send it to their servers, who then might populate that information on their app showing where the truck is. And then we're also in discussions with them about potentially using their geofencing capabilities, that when that truck is backed up to the paver, that would then trigger, again, that kind of two-way communication between APIs to say, okay, this truck is at the back of the paver. Now let's not rely on the dumps person to push that button. Let's let a computer say, okay, I'm there, I accept them there, put that pin there without that need, as you mentioned, Deb, for that guy pushing it 2-3 times because he realizes he's forgotten the last 2 trucks. So yeah, as Rory mentioned, we're actively working on it. It is tough in the sense that truck drivers, as unusual breed in some respects, they don't like things on their trucks, they don't like things on their phones. So it's a challenge. I don't, as Rory mentioned, I don't think it's an insurmountable issue, but I think you've probably just got to use an amalgamation of technologies.
Sounds
Very
good.
good.
Thank you, guys. Thank you.
Thank you for the question, Dr. Mishra. Anybody else have any questions? If you want to raise your hand, we've still got a few minutes left. And if not, then I'll say, Rory and to Matt, thank you very much for your presentation today. It was very informative. Looking forward to the new ASTM standard to come out here sometime soon. I hope we're going to start working on that, get that out for ballot. We will post this information. I'll let Patty tell you where this information is going to end up. It'll come out on social media channels. You'll be able to watch the video. Dr. Mishra put a video out also on the climate challenge that used this technology. So that's an informative video to watch. And then he also told me that they have written a paper on this topic, on this system, that is under review. So it's not quite ready for distribution yet. But anyway, so with that, thank you, gentlemen, for your presentation today. Patty, do you have any parting comments before we let everybody go?
Nope. I'll be sending an email follow-up with a recording of the webinar so that everybody has that information, along with Dr. Mishra's attachments that he put in that chat, so that everybody has that, and the YouTube video that he included. And yeah, this will be posted to social, like you mentioned, as well as Ingevity's YouTube page. So
very good.
Yep.
All right. Well, thank you today for your participation, and we'll see you on the next installment of Connecting the Dots.
Thanks very much.